The darkness of that March night in 1945 was cut through by artificial light so intense it turned the eastern bank of the Rhine River into something resembling midday, though the hour was well past 2 in the morning, and every German officer watching knew that dawn was still hours away. What they witnessed through their field glasses and observation scopes defied not just their expectations, but their entire understanding of military engineering, accumulated through decades of training and centuries of Germanic tradition in bridge construction. Major Hans-Joachim Brenner, serving with distinction in the Wehrmacht's 116th Panzer Division, found his hands shaking as he gripped his binoculars, and he knew with absolute certainty that the trembling had nothing whatsoever to do with the cold air blowing across the river from the west. In his breast pocket, pressed against his uniform, lay a small diary where he had frantically scrawled observations just minutes earlier, words that would have resulted in his immediate court-martial had any superior officer discovered them, words that acknowledged an impossible truth unfolding before his eyes. What Brenner witnessed was not bridge construction as he understood it, not the careful, methodical process taught in every military academy across Germany, not the weeks-long endeavour requiring thousands of labourers and massive machinery pounding pile drivers into riverbeds day and night until the very earth shook with the effort. Instead, he watched something that looked more like factory work transplanted to a battlefield, a rhythmic assembly process where two soldiers would manoeuvre a steel panel into position, lock it into place with what appeared to be simple pins, then immediately step back as another pair of soldiers advanced with an identical panel to continue the sequence. There were no towering cranes struggling against the weight of massive beams, no pile drivers creating the thunderous percussion that should have accompanied such an undertaking, no foreman shouting calculations and adjustments as unique components were fitted together through painstaking individual attention. What he saw instead was rhythm, pure and simple, a cadence that never faltered, a precision that seemed almost mechanical in its consistency, and behind it all an endless stream of supplies flowing forward from what appeared to be an inexhaustible stockpile. The date was March 24th, and the location was near the German town of Wesel, though by this point in the war such geographical distinctions were becoming increasingly meaningless as American forces advanced across territory that German strategists had believed would take months to traverse. The time was precisely 2:47 in the morning according to Brenner's watch, which he checked compulsively as if hoping that time itself might provide some explanation for what he was observing. The Americans were not building a bridge in any traditional sense of the word. They were assembling one, clicking together prefabricated components with the same casual efficiency that a child might demonstrate while playing with construction toys. Except this particular construction kit was stretching across more than 400 meters of rushing water and would soon be capable of supporting the weight of tanks and heavy artillery. When Oberst Wilhelm von Stauffen arrived at Brenner's observation post, his reputation preceded him as it always did, for this was a man who had overseen the construction and deliberate destruction of more bridges than perhaps any other officer in the entire Wehrmacht, a veteran engineer whose experience spanned every theatre where Germany had fought in this war and the previous one. He took position beside Brenner without speaking, raised his own field glasses, and watched in what stretched into minutes of absolute silence. When he finally spoke, his voice carried the hollow, defeated tone of a man watching the fundamental principles of his profession collapse before his eyes. He mentioned Russia, the vast eastern front where German engineering prowess had been tested against distances and conditions that would have broken lesser armies, and specifically he recalled bridging the Dnieper River, a massive undertaking that had consumed 3 full weeks of intensive labour despite the deployment of 2,000 men working around the clock. The bitter irony, he noted with a voice that barely rose above a whisper, was that the Dnieper was actually narrower than the Rhine crossing he was currently observing, and yet what had taken the Wehrmacht 3 weeks with massive resources, the Americans appeared to be accomplishing in a fraction of that time with what looked like a mere fraction of the manpower. The fundamental difference, though neither Brenner nor von Stauffen fully articulated it in that moment, lay in the conceptual approach to what a bridge actually represented. To the Germans, trained in a tradition that stretched back through the Prussian military academies and beyond to the engineering achievements of the Holy Roman Empire, a bridge was inherently a masterpiece, a unique creation where every timber was selected for its specific properties, every joint was calculated to distribute forces according to precise mathematical formulas, every span represented a testament to the skill and knowledge of the engineers who designed it. Each bridge was different because each river was different, each tactical situation demanded its own solution, and the pride of German engineering lay in the ability to create these bespoke solutions that demonstrated mastery of complex principles. To the Americans, however, a bridge was something altogether different in conception. It was a tool, a piece of equipment, a standardized solution that could be deployed wherever needed without regard for uniqueness or individual artistry. Their panels were identical, their pins were identical. Their assembly instructions were so simple and so thoroughly standardized that a farm boy from Iowa or a factory worker from Detroit could follow them without any specialized training whatsoever. The Germans, in their approach, built monuments, structures that would stand as evidence of their engineering capability and organizational prowess. The Americans built tools, objects meant to serve a function as efficiently as possible, without any concern for how impressive they might appear or how much skill their construction might demonstrate. And this fundamental difference meant that while German bridges required highly trained engineers supervising teams of skilled laborers, American bridges could be assembled by ordinary infantrymen following a standardized procedure, which meant that American bridges could be mass-produced by the thousands in factories far from the front lines, shipped as components, and deployed wherever military necessity demanded. Through his binoculars, von Stauffen watched the bridge extending itself outward across the Rhine in a manner that seemed to violate basic physics, cantilevering over open water without any visible support beneath it, defying gravity through what appeared to be some form of engineering magic that his decades of training and experience provided no framework to comprehend. As each 10-foot section reached completion, the entire structure somehow rolled forward on wheels, pushed by men who treated this apparently impossible feat with the casual indifference of workers on an assembly line performing a task they had repeated so many times it had become pure muscle memory. Von Stauffen found himself muttering observations that were less analysis than expressions of disbelief, noting how the bridge sagged nearly a full meter at its center point, a deflection that by all German engineering standards should have indicated structural failure or at minimum a catastrophic design flaw. And yet somehow, impossibly, the structure held, continuing to support its own weight and the weight of the men working upon it, and soon, he knew, would support the weight of tanks and trucks and artillery pieces crossing in an endless stream. Several kilometers away, at his farmhouse command post, General Alfred Schlemm, commander of the 1st Parachute Army, spread aerial reconnaissance photographs across a table and studied them with the grim focus of a man trying to understand the scope of a disaster he lacked the power to prevent. The photographs showed not one bridge, but 6, all at various stages of completion along a 20-kilometre front, some already carrying traffic while construction crews continued to work on adjacent sections. In one particularly devastating image, American armour crossed in single file across a narrow bridge, while engineers simultaneously worked to widen the same structure for two-way traffic, never pausing the flow of military equipment across the Rhine even as they continued construction. Lieutenant Colonel Friedrich Holtzmann, assigned to analyze the American bridging techniques, spread his findings across the table with hands that trembled slightly as he articulated conclusions that contradicted everything his training had taught him to believe about military engineering. His voice carried a strain of professional disbelief as he explained what his analysis had revealed about the American system. Each panel measured 3 meters by 1.5 meters, standardized dimensions that never varied regardless of the specific crossing or tactical situation. These panels connected to each other using simple pins, not bolts that required tools and time to secure, not welding that required specialized equipment and skilled operators, not the complex joints that German engineering favored because they demonstrated technical mastery. just pins hammered into place by hand, creating connections strong enough to support armoured vehicles. The entire system consisted of only 5 different types of components, a stunning simplicity that meant there were fewer pieces to manufacture, fewer pieces to ship, fewer pieces for soldiers to learn to recognize and handle. Every component was light enough for 2 men to carry, eliminating the need for cranes and heavy machinery, which meant bridges could be built anywhere soldiers could walk. The implications of this simplicity were what truly disturbed Holtzman, because what the Americans had achieved was nothing less than the democratization of engineering itself, taking a specialized skill that required years of training and reducing it to a simple procedure that any soldier could perform after minimal instruction. They did not need engineers in the traditional sense. They did not need men with university degrees and specialized knowledge. They needed only soldiers who could follow a simple, standardized procedure, which meant they had an effectively unlimited pool of bridge builders wherever American forces operated. For German defensive planning, these revelations were nothing short of catastrophic, because every defensive strategy developed by the Wehrmacht assumed that rivers meant time. Precious time measured in weeks, time to reorganize scattered forces, time to bring up reserves from rear areas, time to prepare and launch counterattacks that might throw the enemy back across the water. The standard calculation, based on decades of military experience and engineering expertise, held that any major river crossing required a minimum of 2 weeks to construct a bridge capable of supporting armoured vehicles, and this calculation assumed perfect conditions. No enemy interference, clear weather, and adequate supplies of materials. The entire strategic concept for defending Germany itself depended fundamentally on these calculations, on the assumption that the Rhine and other major rivers would provide natural barriers that bought time, and that this time could be used to husband resources, concentrate forces, and mount effective defensive operations. If bridges could be thrown across rivers in hours rather than weeks, if rivers no longer provided the time that defensive calculations required, then the entire strategic framework collapsed. Captain Ernst Richter, commanding an artillery battery tasked with destroying American bridge construction, had spent the night calling down fire missions on the bridge sites, directing more than 500 rounds toward targets that should have been vulnerable to artillery fire, watching through his rangefinder as 88mm shells exploded with precision on the bridge structures. The American response to this bombardment was what troubled Richter more than anything else he had witnessed in the war, because their reaction to direct hits that should have been catastrophic was almost casual in its efficiency. When a shell struck a panel and damaged it, American engineers would remove the damaged component, insert a new panel from their apparently inexhaustible supply of spare parts, and resume construction, sometimes with a delay of only minutes from impact to repair completion. Richter found himself filing reports that used language he would have mocked as hysterical had he read them from another officer, describing the American bridging effort as being like combat against a hydra, the mythological beast that grew 2 heads for every one that was severed because every component destroyed was immediately replaced, making the overall effort unstoppable regardless of the damage inflicted. His estimates suggested the Americans must have thousands of spare panels, possibly tens of thousands, stockpiled and ready for deployment, a level of material preparation that exceeded anything in his experience. The truth, though Richter could not have known it, was far more staggering than even his pessimistic estimates, because the Bailey Bridge, developed by a British design team at the Experimental Bridging Establishment and refined through years of testing and modification, had been mass-produced by Allied industry on a scale that defied German comprehension. At peak production, 650 different firms were churning out 25,000 bridge panels per month, a rate of production that meant the Allies could replace damaged components faster than German forces could destroy them. While the Wehrmacht was reduced to cannibalizing damaged vehicles for spare parts, recycling components from destroyed equipment because German industrial production could no longer keep pace with battlefield consumption, the Allies had industrialized bridge construction itself, turning it into a mass production operation that could supply seemingly unlimited quantities of standardized components to forces operating across multiple theaters of war. When Major General Heinrich von Manteuffel arrived at the front on March 25th, having travelled from headquarters to see the situation with his own eyes rather than relying on reports that seemed too incredible to be accurate, he brought his field glasses to bear on an American Bailey bridge that swayed and flexed under the weight of traffic in a manner that would have alarmed any German engineer, but which somehow continued to function perfectly well regardless of this visible movement. What disturbed von Manteuffel even more than the bridge itself was the nature of the traffic crossing it. Because the Americans were not conducting a careful military crossing with deliberate spacing and planned intervals between vehicles, they were running what amounted to highway traffic, tanks followed by trucks, followed by jeeps, followed by artillery pieces, followed by more tanks. A continuous stream that treated the bridge not as a vulnerable choke point requiring careful management, but as just another piece of road. He asked his staff officers how long the construction had taken, and when they informed him that the bridge had been completed in less than 24 hours, he lowered his field glasses and stood in silence for what seemed to his waiting staff like an eternity. When he finally spoke, his voice was so quiet that officers had to lean in to hear him, and what he said amounted to an admission that everything German military doctrine had taught about defensive warfare had become obsolete. He mentioned how German officers trained their entire careers to exploit rivers as defensive positions, how military academies studied every major river crossing from Caesar's bridges across the Rhine to Napoleon's crossings of the Berezina, how this accumulated knowledge and tradition formed the foundation of defensive strategy. But rivers no longer mattered, he concluded. Geography itself no longer mattered in any meaningful sense, because the Americans had developed systems that made geographical obstacles irrelevant, which meant Germany was fighting the wrong war, applying lessons from the past to a present that no longer followed the old rules. Lieutenant Werner Gross, captured by American forces during fighting near Wesel, found that the experience that shocked him most was not his interrogation, which was conducted with surprising courtesy and professionalism, but rather the casual conversation he had afterward with American engineers who treated him not as an enemy, but as a fellow professional who might be interested in discussing technical matters. One sergeant from Detroit mentioned almost offhandedly that his unit had built the exact same bridge design 50 times during training exercises, 50 identical repetitions using the same components every time, following the same sequence, developing such familiarity with the process that they could perform it almost blindfolded. The comparison he made was to working an assembly line at Ford's River Rouge plant, except the assembly took place outdoors and the product was a bridge rather than an automobile. But the fundamental principle was the same. Repetitive tasks performed so many times they became automatic muscle memory rather than conscious technical decisions. For Gross, whose training had emphasized the uniqueness of each engineering challenge and the importance of tailoring solutions to specific circumstances, this industrial approach to bridge construction was genuinely incomprehensible because it violated every principle he had been taught about what engineering meant and how it should be practiced. German engineers were craftsmen, he had been told repeatedly throughout his education, and craftsmen took pride in creating unique solutions that demonstrated mastery of complex principles, each bridge different because each situation was different, each structure a testament to the skill and knowledge of its designers and builders. The Americans had turned bridge building into muscle memory, reduced it to a sequence of physical actions that required no thought and no specialized knowledge, and in doing so had achieved something that craftsmen never could. They had made bridge construction infinitely scalable, deployable wherever needed by whoever was available to perform the work. Field Marshal Walter Model, one of Germany's most capable defensive commanders, confronted this new reality on March 26th when his staff presented him with consolidated reports from all sectors along the Rhine, and the conclusion he reached was as simple as it was devastating for German defensive prospects. If rivers no longer bought time, if American forces could cross them as quickly as bridges could be assembled, then rivers were not obstacles in any meaningful military sense. They were just terrain features that required a specific solution, and if that solution could be deployed in hours rather than weeks, then rivers did not function as defensive barriers at all. The implications extended far beyond the immediate tactical situation, because if the Rhine did not provide a defensive line that could be held for any significant period, then there was no natural defensive position between the current front and Berlin itself. No geographical feature that could be expected to slow the American advance enough to allow German forces to reorganize and counterattack. At Oppenheim, the American 5th Infantry Division had demonstrated this new reality with brutal clarity, crossing the Rhine without the extensive artillery preparation that German doctrine assumed would precede any major assault crossing, putting the first boats into the water at 10:30 on the evening of March 22nd and beginning construction of a Bailey Bridge at dawn the following day. Within 48 hours, 4 complete divisions had crossed the river using 2 fully operational bridges that carried continuous traffic. Entire divisions transported across a major river barrier faster than German reconnaissance units could even report accurate numbers of enemy forces involved. Luftwaffe pilot Hauptmann Klaus Becker, flying reconnaissance missions on March 27th, despite the overwhelming Allied air superiority that made such flights increasingly suicidal, photographed American bridge sites and was struck by what the images revealed about American operational methods. Through his camera viewfinder, he could see not just bridges, but entire infrastructure installations, multiple parallel bridges carrying traffic in both directions, traffic control points managing the flow of vehicles with what appeared to be the same systems used for highway traffic management in peacetime, even fuel stations established on the eastern bank to refuel vehicles immediately after crossing. The Americans were not conducting a military operation in the traditional sense. They were installing infrastructure, creating permanent support systems as if they intended to occupy the territory indefinitely and wanted to establish the logistics necessary for sustained operations. The psychological impact of witnessing this systematic approach to warfare was devastating for German soldiers who had been taught to take pride in tactical flexibility and operational art, because what they were witnessing suggested that flexibility and art mattered less than systems and procedures, that individual skill counted for less than organizational capacity. Feldwebel Otto Kessler, commanding a demolition team that had successfully destroyed 2 spans of bridges across the Rhine, had celebrated with his men what they believed was a significant achievement, assuming they had bought at least 2 weeks of time before the Americans could resume their advance. The following morning, looking through his binoculars, Kessler watched American tanks driving across a new bridge 500 meters upstream from the bridges his team had destroyed, and his men simply stared in silence because there seemed to be no point in continuing their efforts when every success was rendered meaningless within hours. General Gotthard Heinrici, widely recognized as Germany's master of defensive warfare, a man whose tactical skill had repeatedly delayed Soviet advances on the Eastern Front through brilliant use of terrain and prepared positions, told his staff with absolute conviction that the Bailey Bridge had achieved something more profound than merely enabling river crossings. It had compressed time itself, collapsing the interval between tactical decision and operational result to a degree that made traditional defensive planning impossible. The Germans had planned for the last war, Heinrici observed, assuming that the lessons learned in previous conflicts would apply to current circumstances, while the Americans had invented a new form of warfare entirely, one where industrial production and logistics capacity mattered more than tactical skill or operational art. When German engineers finally managed to capture intact Bailey Bridge components for detailed analysis, examining the materials and construction methods with the thoroughness that German technical expertise was famous for, they found themselves confronted with something that felt almost insulting in its simplicity. The panels were welded steel trusses, robust but not particularly sophisticated in design, connected by massive pins that could be hammered into place by hand using nothing more than a sledgehammer, requiring no special tools or equipment whatsoever. There were no complex calculations required to assemble the components, no specialized knowledge needed to understand how pieces fit together, no demonstration of engineering mastery in the connections or the overall design. Engineering had been stripped down to pure function, eliminating everything that was not absolutely necessary to achieve the objective of creating a load-bearing structure across a gap. Captain Hans Dietrich, who held advanced degrees from Berlin Technical University and had been taught to appreciate elegant solutions to complex problems, examined the captured panels with a growing sense of dismay as he realized what the American design philosophy represented. The genius, he concluded in his analysis report, lay not in what the Americans had included in their design, but in what they had deliberately excluded, eliminating every adjustable component that might allow for customization, removing every special fitting that might demonstrate technical sophistication, creating a system where every piece was exactly identical to every other piece of its type, regardless of where it would be used or what specific circumstances it would encounter. German engineers loved complexity, Dietrich wrote, took professional pride in showing their skill through elaborate solutions that demonstrated mastery of advanced principles, treated engineering challenges as opportunities to display knowledge and capability. The Americans had removed skill from the equation entirely, reduced the entire process to a procedure so simple it could be taught in hours and mastered in days, which meant they had made bridge construction independent of the availability of highly trained engineers. Major Bernhard Ramacke, commanding paratroopers defending the Rhine crossing near Ries, had watched American engineers working on bridge construction under direct fire from his positions, and had launched 3 separate attacks against the bridge site despite taking terrible casualties in each assault. What disturbed him more than the casualties was the nature of the American response to his attacks, because when his paratroopers succeeded in killing American engineers working on the bridge, replacement engineers would literally step over the bodies of their fallen comrades and continue driving the same pin into the same hole, with no visible confusion, no delay while new workers tried to figure out what needed to be done, no pause in the construction rhythm at all. The bridge never stopped advancing across the river regardless of German attacks, and this inhuman efficiency, as Ramacke described it in his reports, suggested that individual workers were entirely interchangeable parts in a larger system that could continue functioning regardless of personnel losses. The German High Command's War Diary entry for March 28 recorded the situation with bureaucratic precision that concealed mounting desperation, noting that enemy forces had completed 40 bridges across the Rhine, that destruction efforts had proven ineffective because damaged sections were replaced within hours, and concluding with the devastating assessment that rivers no longer constituted significant obstacles to Allied advances. General Hans Krebs, tasked with preparing an assessment for Hitler's review in early April, wrote with careful phrasing what every German general already understood, but few dared to state explicitly, that enemy bridging capacity had made traditional defensive warfare impossible to conduct, that American forces could advance as rapidly across rivers as they could across open ground, eliminating the natural barriers that defensive doctrine depended upon to channel and slow attacker movements. Hitler, isolated in his bunker and increasingly detached from military reality, refused to accept these assessments, dismissing them as defeatism, and demanding that his generals find ways to hold river lines regardless of American bridging capabilities. But the generals themselves, whatever they told Hitler, knew the truth with absolute certainty, understood that American engineers would build bridges wherever military necessity demanded, faster than German forces could possibly react, making river barriers meaningless as defensive positions. Colonel Wilhelm Wilke, observing American engineering operations from a concealed position, was struck by details that spoke to fundamental differences in how the two armies approached warfare itself, noting that American engineers worked with radios playing popular music, took regular coffee breaks in rotation without ever allowing construction to pause, treated the entire operation with a casualness that seemed almost disrespectful to the seriousness of combat operations. They had removed drama from war, Wilke concluded, transformed what should have been a desperate assault crossing requiring maximum effort and sacrifice into a routine construction project that might as well have been taking place in peacetime America. This casualness reflected the material abundance that undergirded American military operations, a luxury that German forces could barely comprehend after years of shortages and rationing. Germans hoarded every piece of equipment, carefully conserved supplies, treated each resource as precious because replacement might never arrive. Americans treated warfare as Germans treated industrial production, as a standardized, mass-produced operation that was infinitely repeatable because the resources would always be available, supplies would always arrive, damaged equipment would always be replaced, losses would always be made good from inexhaustible stockpiles. The comparison that Wilcke drew was between artistry and industrial system, between craftsmen who created unique solutions and factories that produced identical products. And in modern warfare, the factory approach was proving superior because it could be scaled without limit, whereas artistry was inherently limited by the availability of skilled practitioners. During March 1945 alone, American engineers constructed 60 Bailey bridges across the Rhine and its tributaries, a rate of construction that made defensive planning essentially impossible because by the time German intelligence identified a bridge site and organized a response, the bridge would already be operational and carrying traffic. The longest single bridge, constructed at Ries, stretched 1,814 feet and was completed in 52 hours, a span and construction timeline that German engineers simply declared impossible based on their understanding of engineering principles and construction methods. Field Marshal Kesselring, taking command of German forces in the West during the final weeks of the war, issued directives that essentially acknowledged defeat on this specific issue, ordering that rivers could no longer be considered primary defensive positions and that new doctrine needed to be developed independent of geographical obstacles. But there was no time to develop new doctrine and no resources to implement it, even if such doctrine existed. The war was ending. Its conclusion accelerated by those steel panels that ordinary soldiers assembled into bridges using nothing more than hammers and muscle power, and German commanders who had spent careers studying the operational art of warfare found themselves defeated not by superior tactics or better soldiers, but by better systems, by an enemy who understood that modern industrial war was fundamentally about production capacity and logistics efficiency, rather than tactical brilliance or operational finesse. General Heinz Guderian, the father of German armoured warfare doctrine and a man whose tactical innovations had revolutionized military thinking across the world, told his American interrogators after the war that if they wanted to understand how the Allies had won, they needed to look at bridges rather than battles, because Germany had known how to fight and had proven that knowledge in France, in Russia, in Africa, demonstrating tactical and operational skills that matched or exceeded those of any army in history. But the Americans had known how to build, had understood that modern warfare required the ability to construct infrastructure faster than enemies could destroy it, and in this kind of war building mattered more than fighting because all the tactical skill in the world meant nothing if you could not move forces where they needed to be when they needed to be there. Colonel Hans von Luck, a highly respected panzer commander whose tactical abilities had earned him grudging admiration even from his enemies, was even more specific in his analysis of what had changed, stating that the Bailey Bridge had removed geography from warfare as a significant factor, rendering rivers that had shaped European military conflicts for more than 1,000 years essentially irrelevant to operational planning. As Germany surrendered in May 1945, the full scope of American and British bridging operations became clear from captured records and post-war analysis, revealing that Allied forces had manufactured over 200 miles of Bailey bridging components during the course of the war, enough to stretch from London to beyond Dover if laid end to end, and had constructed more than 4,000 individual bridges using these components across all theatres of operation from North Africa to Northwest Europe. Major General Friedrich Schulz, reviewing these numbers and contemplating their implications, summarized the situation with brutal clarity in his analysis, stating that German forces had not been defeated by better soldiers or superior tactics, had not lost because American infantrymen were braver or more skilled than Wehrmacht soldiers, but had been defeated by better systems, by an enemy who had industrialized engineering itself and created organizational structures that could deploy this industrialized engineering wherever military operations demanded it. Field Marshal Montgomery, commanding Allied ground forces during the Rhine crossing operations, would state publicly after the war that without the Bailey Bridge the Allies could not have won the war in Europe, or at minimum would have required several additional years to achieve victory. because every major advance required crossing rivers, and without the ability to bridge those rivers rapidly, the pace of operations would have slowed to a crawl. Wilhelm Keitel, signing Germany's unconditional surrender as the senior Wehrmacht officer, admitted in conversations with Allied officers what German leadership had grasped far too late to affect the war's outcome: that Germany had prepared for a war of movement and tactical maneuver, had trained its officers to excel at operational art and tactical improvisation, had created an army designed to win battles through superior skill and flexibility. What they had gotten instead was a war of production and logistics, a conflict where the ability to manufacture equipment and move supplies mattered more than any tactical innovation, where training builders proved more valuable than training soldiers, where systems defeated skill at every level of warfare. The Bailey Bridge, Keitel observed, was not merely a bridge in the conventional sense. It was a perfect embodiment of everything German military leadership had failed to understand about modern industrial warfare, a symbol of how the nature of conflict had changed in ways that German doctrine and German thinking had not adapted to recognize. General Gotthard Heinrici, perhaps the most thoughtful of the senior German commanders and certainly one of the most capable defensive tacticians the Wehrmacht produced, provided what might be considered the final German assessment of what the Bailey Bridge represented, stating that Allied Bailey bridges had crossed not merely the Rhine River but 2,000 years of military history, leaping over accumulated wisdom and traditional understanding to create a new form of warfare that made old principles obsolete. The Germans had not defeated the river, Heinrici observed. They had made the river irrelevant to military operations, eliminated it as a factor in operational planning, and in doing so had fundamentally altered how wars would be fought in the industrial age. The Rhine still flows through Germany today, just as it has flowed since Roman legions first encountered it, following the same course, presenting the same physical barrier to movement, maintaining the same width and depth and current that made it a formidable obstacle for thousands of years of European history. But in 1945 its meaning changed forever, because for the first time in recorded military history, rivers no longer shaped the conduct of warfare in any fundamental sense. Systems did instead, organizational capacity did, industrial production did, logistical competence did, and all of these factors favored the Allies, and particularly favored the Americans who had built their entire military approach around these principles. The German generals who stood watch through those March nights, observing American Bailey bridges rising across the Rhine faster than they had imagined possible, faster than anything they believed could exist based on their training and experience, had failed to imagine not just specific equipment, but an entire philosophy of warfare where building capacity mattered more than fighting skill, where efficiency defeated elegance every time they came into conflict, where the assembly line approach to military operations conquered the craftsman approach that German military culture had perfected over generations. These men had been the last generation of European military officers to believe that geography fundamentally determined strategy, that rivers and mountains and other terrain features shaped what was possible and what was impossible in military operations, that understanding terrain and knowing how to exploit it represented the highest form of military art. The Bailey Bridge proved them wrong, demonstrated conclusively that in modern industrial warfare, terrain mattered only insofar as it affected the speed with which industrial systems could be deployed to overcome it, and that speed was now measured in hours rather than weeks. One prefabricated panel at a time, hammered together by soldiers who might never have seen a bridge before their military service, who required no special training or specialized knowledge, who simply followed simple instructions and repeated simple procedures. American and British engineers crossed every river in Germany, collapsed every defensive line, made every natural barrier meaningless, and in doing so ended not just a war, but an entire era of military thinking that had lasted since warfare began.